As we hop into the new unit of exponents and exponential functions, it's going to be really important for us to understand the properties of exponents, and that's what we're going to learn about today. Now, last class we talked about a base or variable and the power associated with, or the exponent. We talked about how to add or combine like terms with adding or subtracting. Remember, we learned that the base and the power have to be the same for us to add or subtract these things together. However, when we get into multiplying and dividing and many other operations for these exponents, the rules change, so we need to make sure we understand those rules. These are called the product rule, quotient rule, power rule, negative exponent rule, rational exponents, and zero exponent rules. That's a lot, but really the rules are quite simple. We have an acronym that's going to help us with the first three rules. Now that acronym is called MADSPAM, M-A-D-S-P-M, MADSPAM. Now MADSPAM is pretty cool because it actually contains hints for the first three of the exponent rules. For MA, we're talking about if we multiply bases, all we're going to have to do is add the exponents together. If we're dividing bases that are the same, all we do is subtract the exponents. And if we have a power raised to another power, or if you see parenthesis powers, you're going to multiply those exponents together. So the first letter has to deal with the bases, the second letter deals with the exponents. If we multiply the base, we add the exponent. If we divide the base, we subtract the exponent. If we have a power raised to a power, we multiply. Let's talk about each of these rules in general. So, product of powers property is the MA. So if we multiply the bases, we're going to add the exponents. On your formula chart, it looks something like this. Let's say we have a to the m, so any base a raised to some m power, and we're multiplying it by the same base to a different power. To simplify this, all we have to do is add those exponents together. And voila, we've simplified. Check out our easy example here. X to the second power times x to the sixth power. Since those bases are the same and I'm multiplying, multiply the bases, add the exponents. I've simplified it. For the second easy example, we've got an invisible exponent of 1 chilling right there, which means when I multiply these matching bases together, I'm going to do 1 plus 5 to get y to the sixth power. That's the product of powers property. Multiply, add. The second one is the quotient of powers property. Quotient is the fancy math term for division. We're finding the quotient when we divide, which means we're just going to subtract the exponents. On your formula chart, it looks a little something like this. You've got a to the m over the same base a to the n. We can simplify that by doing a to the m minus n. So if your bases match and you're dividing, you're just going to subtract the exponents. Don't overthink these rules. X to the fifth divided by x squared is going to be x to the 5 minus 2, which is 3, because we're subtracting the exponents. In the second easy example, what's the invisible exponent for the denominator y? Yeah, it's another 1. Invisible exponent is 1. So here, since I'm dividing y squared divided by y to the first power, I'm just going to be doing y to the 2 minus 1, or y to the first power. The last part of MADSPAM is the PM. That's the power of a power property. P to an M, okay? Now what that looks like is, let's say you have the base A and it has an exponent, but then that entire term is inside parentheses and raised to another power. So it's called power of a power. If you think parentheses power, that might be a nice way to think about it. But when we have parentheses powers, what we're going to do is we're actually going to multiply those powers together. Now this is not distribution. Let me make that very clear. But you can kind of think of it as exponent to exponent distribution. You're distributing the outside exponent to all of the exponents on the inside. It is not distribution, but it is kind of nice to think of it like that. Let's check out these examples. You've got x to the second power, that all raised to the fourth power. which means we're going to do a little bit of this, and we're going to get x to the 8th power, 2 times 4. If I wanted to simplify the second one, remember we have to distribute to everything on the inside, and we're distributing, I'm using air quotes but you can't see me, we're distributing to the exponents, which means this 2 is going to pop on over and multiply by that 3, and it's going to pop over to the exponent of that number 3. What's the invisible exponent of the coefficient 3? Yeah, it's a 1. So this is going to be 3 to the 1 times 2 power, which is 2, and y to the 3 times 2 power, which is 6. Now that's an acceptable answer, but it's not really simplified because we've got a good old-fashioned number there that's raised to a power. When a good old-fashioned number is raised to a power, you can go ahead and multiply. 3 squared is 9. So we'd actually want to stop simplifying this all the way at 9y to the 6th power. Now the next exponent rule is not a part of MAD/SPAM. It actually has its own acronym that we use at our school that is called Tebow, like Tim Tebow but spelled wrong. So Tebow stands for top goes in and bottom goes out. Now the reason that this is helpful is because with rational exponents, this is like a fraction exponent, a to the m over n. So see how the exponent itself is a fraction? Well, we can rewrite that in what's called radical form by taking the top number and putting it on the inside of this radical sign, and taking the bottom number and putting it bloop right on the outside, like sitting on the little shelf. So we're rewriting rational or fractional exponents into a radical form. Okay, let's see. We have x to the 7/5, and we want to write that in radical form. Let's go ahead and set ourselves up for success. We know that there's going to be a radical. That's the square root sign, but we're going to call them radicals because that's their actual name. And we're going to put that base in there. Then we say Tebow, top number, which is 7, goes inside. Bottom number, which is 5, goes on the outside and sits on the little house. That is called the 5th root of x to the 7th. Now that's kind of wild. So let's go backwards and make sure we still understand this. In the second example, it's a 3rd root of x squared. Well, if the top went in and the bottom went out, the bottom number or the outside number has to be 3, and the inside number or the top number has to be 2. So we can use Tebow to go backwards and forwards from rational exponent or fractional exponent form to radical form. Those are the main exponent rules we're going to deal with today, but we're going to make sure we have some easy examples just to get the hang of the properties themselves. There are 2 other, general speaking, other exponent rules that we like to use. The first one is called the negative exponent property. Now here's the thing, we like to keep our work nice, neat, and clean. So what's kind of ugly is having a negative exponent. Ew. We like things to be positive. So when you get a negative exponent, you got to think, hammer time. Because we're going to hammer that guy down to the bottom, so the entire term, bloop, drops down to the bottom, and now it's positive. Can't leave just a numerator blank, so you're going to put a placeholder number 1 in there. And now we're happy because everything's super positive. We don't want negative exponents, so we're going to hammer time it down into the denominator. Notice that nothing else changed. The only thing that changed is that the location became the denominator and that negative exponent became positive. So if I wanted to simplify x to the negative 2 power, I would say hammer time and hammer that down to the bottom so that it's positive and put a little placeholder there. Same thing with negative 2 to the negative 5th power. I'm going to take that negative 2 because that's the base. Don't change the base, ever. I'm going to plop it down into the denominator, and I'm going to change my power to be positive. Hammer time. Just changing the exponent only from negative to positive. The last exponent rule here is the easiest. That's why we saved it for last. Best for last. There is a really special property that happens whenever you have an exponent of 0. So anything, no matter what it is, raised to the 0 power is 1. Like a good old-fashioned number 1. Not an exponent of 1, a 1. So don't overthink this. What is 4 to the 0 power? 1. What is, let me take a deep breath here, 98,347,529,354 to the 0 power? Yeah, that thing's 1 as well. So it doesn't matter what it is, the term that is raised to the 0 power is 1. Don't overthink that. Phew, we've talked about a lot of rules already, but we're just going to be working on these straightforward examples in the first part of class. We'll be working on the challenge examples next class, so don't lose these notes. In the meantime, please, please, please remember that the exponent properties are actually mostly all on your formula chart. So you don't have to memorize these if you can look at the reference and know what it means, but it is also easier just to know what the exponent properties are. All you have to remember is MAD/SPAM and Tebow, which are 2 acronyms that will really help us remember these exponent properties as we start using them in larger problems. See y'all in class.